Hello and welcome to the video on multiple representations of functions. Yes, there's music going on in the background. The reason for that is simple. Sometimes I bore myself with these videos. So maybe you like the music, you keep watching, you keep listening. Well, either way, it's good math info. So here we go. We can represent functions with words, equations, tables, and graphs. Are you ready? This is exciting stuff. That's why we got the music on here. Alright, a robot is running a marathon and keeps a constant speed the whole time. He covers a distance of d miles while running 8 miles per hour, t, throughout the race. Represent this function using words. Well, if we just go through and highlight some things here. A robot is running a marathon and keeps a constant speed the whole time. Okay, that means it's going to be linear. It never changes. He covers a distance of d miles. Okay. While running 8 miles each, even though it doesn't say the word each there, we can interpret it that way. 8 miles each hour throughout the race. Represent this using words. Well, basically what he's doing is he's running a distance, d, so he's running a distance of miles, and that changes based on how many miles or how many hours he runs for, but we know he runs 8 miles each hour. So what I would say is that the distance is equal to the number of hours times the speed of 8 miles each hour. So having said that, same problem, robot still running the marathon. Represent this function using an equation. Well, if we remove this here, we'll see that the distance, d, equals 8, which is the speed, 8 miles per hour, times the time, which is how many hours that the robot happens to run. That's all you need to do to create the equation. Alright, now we're going to represent it using a function table, a table here. So again, we have this equation here, d equals 8 times t, and we're saying that time is the variable t. So if we have 1 hour, whoa, the music's getting crazy, huh? We could use the equation d equals 8 times t. I actually haven't previewed this music, just so you know. D equals, I just went to YouTube and clicked this thing and searched movie soundtrack, so we'll see what we get. D equals 8, our speed, 8 miles per hour, right? We got that from up here in our problem, 8 miles per hour. And we're saying that there's 1 hour the first time, so 8 times 1. D equals 8 times 1. Well, then D would equal 8. The distance would be 8 miles. So I would put this over here in our little table. We get 8 miles. And then if we did the same thing, D equals 8 times T. And this time we substituted 2 for T. D would equal 8 times 2 is 16. So we'd write that in our chart now, 16 miles. And if we did the same thing for D equals 8 times T, we would get, when there are 3 hours, 24. So 8 times T, and we would do D equals 8 times 3. So D would be 24 miles. We've just represented this using a table. We've represented it, remember this, doing an equation. We've also done, remember this, we've done it with words, right? Oh, I gotta bring it up. This is exciting. And now, lastly, we're going to represent this as we promised using graphs. So we've got our graph here, and you remember our table? We can actually use our table to help us out. So 1 hour, it's 8 miles. So I'm going to put a point on the graph here at 1 hour and 8 miles. So that would be right here. And then we also said on that table, 2 hours was 16 miles, and 3 hours was 24 miles. So I can plot those points. So we had 2 hours, and we're lining that up with 16 miles, and then 3 hours and 24 miles. And you'll notice this will actually form a straight line here. And this graph will go on and on forever. So you start at 0 miles and 0 hours, right? And then you're going at a constant speed the whole time. So basically at a half hour you've gone 4 miles. That makes sense. At 1 hour you've gone 8 miles. And then we're just going to keep going all the way up. This thing will go on forever because it's a constant speed. It said it's always running 8 miles per hour. It's a robot. What can you say? Anyway, I hope you enjoyed this video on multiple representations of functions. Again, we can do graphs, we can do tables, we could use equations, and we could even use words.